finally, for the last kind of pharmacological of anxiety lecture, we're going to talk about the type of drugs that I'm sure you guys are most excited to hear about, and this is how cannabinoids play a role in anxiety. So endocannabinoids are modulators of the HPA axis activation. So remember, endocannabinoids are kind of your body's naturally produced cannabinoids. So cannabinoids act similarly to endocannabinoids. Okay. So there's two main endocannabinoids that I'd like you to know. So that's anandamide and 2-AG. Okay, so if you're looking in this diagram here, we've got the presynaptic terminal on top, postsynaptic on the bottom. And so the postsynaptic dendrite will send these endocannabinoids back to the presynaptic terminal, and they act on the CB1 receptor, okay, the cannabinoid 1 receptor, which is in the presynaptic terminal. And what this CB1 receptor does is it sends an inhibitory response about the release of neurotransmitters. Okay, so it's an inhibitory receptor, and it's retrograde inhibitory neurotransmission. So it prevents activation of the CB1 receptor, will inhibit release from the presynaptic neuron. So what are the links of the cannabinoids or the endocannabinoids with the HPA axis? So under a steady state conditions, then the CB1 antagonism results in an increase in the glucocorticoid release. Okay, so by antagonizing the CB1, it antagonizes things and it results in the increase. So it's suggestive of a steady state endocannabinoid suppression of the HPA axis. Now we see that microinjections of the CB1 antagonist into the PVN, the hypothalamic paraventricular nucleus, does not affect the glucocorticoid release. However, direct microinjection into the basolateral amygdala, so right here, so if we directly inject one of our endocannabinoids, such as anandamide, then what we see is that by inhibiting that, then we get more to the glutamate, will then tell the PBN to actually increase its glucocorticoid release. Okay, so we see more glucocorticoid release here, which then can act on the PBN, increasing the HPA output. So the basolateral amygdala projects directly and provides excitatory input to the PBN. Now, early experiments noted that CB1 knockouts or administration of a CB1 antagonist caused a marked increase in circulating corticosteroids. So even if administered at the dineural nadir or the trough of the corticosteroid release. The agonists are good, but antagonists not great. So what about during a stress response? Well, here you can see the CB1 receptor on the presynaptic cell. You can see where the you see the endocannabinoids here. I don't know why I forgot that word, I just said it. But under conditions of stress, then the anandamide levels in the BLA drop as a result of FAAH induction. In other words, normally we've got a lot of these endocannabinoids going, which lead to the inhibition of glutamate release. But during stress, then we see less and less of these endocannabinoids due to the increase of FAAH. And what this does is it means that we no longer get the activation of CB1, which means more glutamate can be released from the presynaptic cell. And due to the decrease in our endocannabinoid anandamide, levels will release the inhibitory tone, leading to excitatory output to the PBM. So CB1 agonists administered to the BLA will suppress stress-induced activation of the HPA axis. Okay, so during stress we have increased activation of the HPA, but if we give ourselves a agonist of the CB1, then we can turn this back to looking like normal. Now we've also got some negative feedback going on. So glucocorticoids can act directly on the hypothalamus or pituitary to provide negative feedback, preventing excess glucocorticoid release. Okay. So rapid feedback in the PBN can be blocked by microinjections of CB1 antagonists. So the role of endocannabinoids in controlling the negative feedback. Okay, so you can see how 2-AG is playing a role in the feedback. So slower mechanisms for negative feedback involve the limbic system. So 2-AG levels increased, resulting in inhibition of the GABA interneurons. Okay, so normally you've got GABA interneurons, but because we've got 2-AG, then we're inhibiting the GABA, which means HVC and the medial prefrontal cortex will continue firing. They will send their excitatory output. So the cortical output of the BNST is disinhibited. So normally it's inhibited because these guys are inhibited, so it doesn't tell him to activate, but because he is disinhibited, then he can send his inhibitory input to the PBN. So the net increase in inhibitory output from the BNST to the PBN attenuates the stress response. So endocannabinoids in the stress response, then endocannabinoids modulate activation in response to stress. So AEA inhibits amygdala activation, and FAAH induces the release of AEA inhibitory tone on stress. So endocannabinoids modulate the recovery from stress as well. So 2-AG synthesis in the PBN will contribute to the rapid negative feedback. And 2-AG synthesis in the prefrontal cortex and hippocampus contributes to slow negative feedback. So how do endocannabinoids work in anxiety? There's no evidence that endocannabinoids are causally involved in anxiety disorders. So people don't think that it's a that there's something wrong with the cannabinoids or endocannabinoids in people with anxiety normally. More just that you can take cannabinoids to help with the effects of anxiety. So there's a common genetic variant in FAAH that decreases the rate of breakdown of anandamide, which is one of the endocannabinoids, and we see this in about 20% of North Americans. So increased levels of the anandamide is seen throughout the brain, so perhaps that is a role. So FAH variant is associated with a reduced risk of anxiety disorders and PTSD as well. So with this This gene, C385A group, shows reduced amygdala response to threat cues, enhanced fear extinction, and an increased prefrontal cortex amygdala connectivity. This gene is also associated with reduced stress response and anxiety in PTSD as well. In an animal model, then FAAH mutant mice showed decreased anxiety in tests such as the elevated plus maze and more rapid extinction of conditioned fear responses. So FAAH antagonism is a putative therapeutic target for anxiolytic drugs. And that is it.